Hi, thank you very much. Just like Jim Bethke, I spend the majority of my time in the ornamental industry, in a greenhouse, and that's the DRAMM company's been around for 60-some years, 70 years. In 1945, John DRAMM invented a watering tool called a water breaker, and it was meant to basically hand water plants. From that point, DRAMM really was all about new efficiencies. Moved into a bunch of different other things, irrigation, environmental control. Where I primarily spend a lot of my time is in pesticide application. The DRAMM company makes 35, 40 different sprayers, different sizes, shapes, types, all for indoor use, in greenhouses. We don't make boom sprayers, we don't make orchard sprayers, we don't make mist blowers, anything like that. We make things that are meant to be used in a greenhouse. You guys are starting to look into greenhouses and more controlled area agriculture. Jim asked me to come and talk to you guys today about types of application methods that you might use in those type of situations. When we talk about effective pesticide coverage, we're going to talk about a number of different things. The equipment has a big bearing on what you are doing. The types of machines that you're going to use are going to be different than you're going to use in the field. There's a wide variety. I'm going to break those down for you. We're going to talk a little bit about training, how to use that different equipment, and things you should be doing on your nurseries to make sure that you're getting the most effective use and coverage. One of the things that Jim mentioned is, one of the problem areas, one of the reasons for pesticide failure or control failure is because the pesticide didn't get to where it needed to go. And that's really what we spend our time working on, is making sure that the pesticide gets to where you need it to go. Technique kind of goes hand in hand with that. There's different techniques you should be using and looking at with different types of equipment. As we move indoors, you're going to have very different techniques than you're going to be using outside. I've got a pesticide applicator's license in the state of Wisconsin, a little bit different than California. When I go to get my license there renewed, the testing is all about spraying corn and, boom sprays and calibration. In a greenhouse, it's very different than that. It's not a typical ag-type application. In fact, now I'm actually teaching courses there for the greenhouses so that we get more proper stuff. But the idea is it's very different, and so we'll talk about that. And finally, if we have a couple minutes, I'm going to talk about maintenance. We do a lot of training, but primarily we're an equipment manufacturer. My least favorite phone call to receive is 5 o'clock on Friday. You've got a tank full of pesticide and something's wrong with your machine, because I can't help you. Okay, when we talk about different types of things, particle size is going to be very, very important to this discussion. All right? Droplet size is really where it's at as far as getting good coverage. We're going to have even coverage over a plant. We're going to need to basically use different size particles to help us do that. Coming from the outdoors and coming into the indoors, it's a very different set of rules. Outdoors, we're worried about drift. We're worried about it going places where we don't want. So we do things to make that droplet size optimal for outdoor application. In the greenhouse, we don't have those constraints. I'm not worried about it drifting or minimal drift issues. In some instances, drift is really something I'm trying to achieve. So particle size is going to be important, and we're going to talk about that. Basically, this symbol is the symbol for micron, which is a unit of measure. Okay, it's a linear unit of measure, like an inch or a foot or a yard. It's just very, very small. Your hair is about 100 microns in diameter on average. Okay, 100 microns is going to be important because that's one of the dividers we place on the particle size world. That's starting to get into a bigger droplet. Bigger droplets fall faster. Bigger droplets run off plants. Really big droplets become runoff and drip away. Very, very fine droplets float in the air. So particle size and a knowledge of different particle sizes is going to be important to our discussion. When we talk about, some very important relationships exist when we talk about particle size. We take one droplet of water that is the size of your hair, or 100 microns in diameter, okay? We take that droplet And we take that same volume and we chop it up into droplets that are 10 microns in diameter. What you're doing is you're going to cover a lot more surface area because we're going to get about 1,000 droplets with the same volume contained in the 100 micron droplet. What's happening here is you're chopping up those droplets so finely, okay? You're doing almost what a chemical surfactant would do in this point, and you're reducing the surface tension of the water. Mechanically, we're reducing the surface tension because we're just making it into smaller droplets. You can cover a lot greater surface area with this. The term low volume, you may have heard this. It's used in aerial application. We use it a lot indoors. Low volume application refers to the amount of solution that you are going to use to do the job. It's not about the pesticide. It's about the amount of solution used to achieve coverage. This is why we can take that 100 micron droplet that's the size of your hair, cover a lot greater surface area with that same volume. The result is that we can generally start to reduce the volume of solution needed to cover the area. So this relationship even extends a little bit further. Let's say we've got one 100 micron droplet, okay? That's the one on your left. That 100 micron droplet, let's just say same exercise as before. We're going to chop it up into smaller droplets. We cut it up into 50 micron droplets. We're going to get 8 droplets for every 100 micron droplet, volumatically. Okay? That's going to help us cover more surface with that droplet. If I drop that, as I said before, if I cut that down to 1/10 of the original size, or 10 microns, I'm going to get about 1,000 droplets. And actually not on the slide, if I go one more scale past this and I go to a 5 micron, or 1/20th of the size, I'm going to get about 19,000 droplets with the same volume of solution contained in a droplet the size of your hair. We're able to cover much, much greater surface area by doing that. Now, this relationship is not static, 100 microns, 50 microns, 10 microns. Anytime that I take a droplet and I cut it in half, I'm going to get 8 times more droplets per volume. So, if we take the hydraulic sprayer and we do some things to maybe increase its performance without buying new equipment, it's very easy to change tips to get a finer spray. It's easy to increase the pressure or use the full pressure range of your pumps. It's very easy to go from a 1,000 micron droplet to a 500 micron droplet. The result is you're going to cover more surface area by doing that. You're going to get a finer spray. When we're in a greenhouse, we really don't care about the drift that much. I'm not worried about it blowing off into someone else's field or onto other crops. I'm able to control it and aim it because I don't have wind moving around in there. Hopefully I've shut off my HAF fans while I'm spraying, and I don't have those issues. So finer droplets in a greenhouse is going to be really one of our goals. We want to get a fine spray because you're going to cover more surface area. You're going to do a better job of covering the plant when you do that. Now, to illustrate this a little bit further, this is one of our friends in the greenhouse industry, the greenhouse whitefly. He's common to yours as well. He's about 1.2 millimeters in length. If we take the 100 micron droplet, and that's all we have, that's what it looks like compared to him. Okay? We got 100 micron droplet. If we take that same amount of volume and we put it into 50 micron droplets, that's what it looks like. If we break that down into 10 micron droplets, that's what that looks like. We can cover much greater surface area, hopefully contacting the insects and diseases a lot easier. Now that you all understand about particle size, we'll focus that on the different types of machines that are actually out there. We kind of see the world in 3 different distinct categories when we're talking about indoor application. We look at the hydraulic sprayers, okay? This is very standard. Everybody's familiar with this. This is just a pump. It's pressurizing a hose to a gun, and you are pulling a trigger and spray's coming out the end. There's a wide variety of different machines and pump designs, gun designs, hose designs, everything else that can swing this from very small droplets to very large droplets, but it's basically one category. It's possible to improve these, but it's still one category. We move into targeted low volume. This is droplets that are a little bit smaller, but it's still something that you can aim. We've got different types of low volume. Low volume is, like I said, we're using less volume, we're creating smaller droplets. Targeted low volume means that I can aim it, and it's going to go pretty much where I aim it. It's not going to float everywhere. Whereas ultra low volume, this is space treatment. This is a flea bomb. Your dog comes home with fleas, you set the can off in the house, that's ultra low volume. We want that to go into every nook and cranny in that building because the fleas are going to go in every nook and cranny. We want to get them where they are. And spraying directed isn't always the best way to do that. So we've got 3 different distinct categories. Each one of those basically has some very, very standard characteristics. Regular hydraulic sprayers, high flow rate. You're getting things wet. Spray to the point of runoff is a very common term in the ornamental industry on every pesticide label. It's one of those terms that I always have struggled with because if you're going to spray to the point of runoff, that's a very hard thing to determine. Spraying past the point of runoff is very easy to know, but just about when those plants are going to start dripping, that's a very hard thing to gauge. Standard chemical rates. The labels say mix X amount of this pesticide into 100 gallons and spray to the point of runoff. That's just all standard. Like I said, wet. Sometimes too wet. Often you can waste a lot of pesticide using this type of method because of how much actually runs off the plant. We want to, that's where some of the other methods don't have that concern. And then finally, particles larger than your hair, typically. When you get bigger than 100 microns, droplets start to fall faster. 100 microns is still pretty fine for a hydraulic spray. Most of the hydraulic sprayers on the market are more in the 1,000 micron range for an average particle size. When we talk about, I should really mention something with particle size that's really important. Volume mean diameter is what we're discussing when we talk about that average particle size. It means half the volume of solution is bigger, half the volume is smaller. Range is another thing that's very important when we're looking at particle size. If I've got an average particle size of 100 microns, but I got a bunch that are 1,000 and a bunch that are so fine they're just floating around, telling you that it's 100 microns isn't really very helpful because it's just telling you what's in the middle. Range is always an important number a characteristic to know as well. And as we talk about different machines, there will be different ranges, and I'll discuss those as well and how those are effective and how you need to think about those things. So hydraulic sprayers primarily, basically this is a little sprayer we make for indoors in the greenhouse. That actually right there is creating about 125 micron droplet. It's a very fine spray. One of the things you can do when you're looking at particles as they spray is to see how much is falling. It's a really good gauge to see how big the particles are. It's a very unscientific method. There's other machines and tools that we use to actually measure particle size. We don't really do it in the greenhouse, though. Something like that's creating about 120, 150 micron droplet average. It's very, very fine spray for a hydraulic spray. But you see, it's also a lot of swirling that you don't see when you get a real heavy wet spray. That is done by just using 500 psi and a very, very fine tip. And that's what I would suggest to you is if you have machines capable of that and you're bringing them indoors and you're used to using them outdoors at 200 psi with a real heavy wet spray, a tree gun, things like that. Spraying a tree is a very different thing than spraying inside of a greenhouse. That's something like getting a finer spray is going to get you better coverage. Targeted low volume is the next category that we mentioned. Basically what we're doing here is we are using a lower flow rate. A lot of times it's still a hydraulic pump like a hydraulic sprayer would be. We've got other types of methods on the right. We've actually got a rotary disc atomizer. You have a little disc that spins at a controlled rate of speed. Solution is dripped into that disc. Typically, there's little grooves in that disc with teeth, and so what it does is those grooves separate the solution, run it out to those little teeth where the droplets get spun off. This is a really nice method because it gives you a very precise droplet size, depending on the speed and the flow rate that you put into the disc. They're generally very small, though. These are spot treatment tools. These are to be used like Jim suggested. If you got a problem, don't spray the whole greenhouse. If you know it's over here at the door, go use a tool like this at the door to get the problem early. As long as you're scouting and you know it's there, go hit it. It doesn't pay to treat the whole greenhouse. Not great tool if you have to treat the whole place. Very small, very portable. There's other types of machines. There's air atomizing systems that create a droplet that's sized for this. But all of these share one characteristic, in that the droplets are the right size that you can aim them. Okay, they're not going to float around. Typically, we're going to use a little bit of a reduction in chemical rates. That's mainly because we're not running it off the plants with this. You're barely going to see the wetness on the foliage with this. It's going to be a very, very dry application. Okay, it's not going to be spray to the point of runoff. You're not going to have a real good visual indicator that this is doing what it's supposed to do. Technique, very important with this type of method. You want to see leaves rustle, you want to see leaves lift up, but you're not going to be seeing them run off. This is actually, of any of the different equipment that we have, that we sell and we work with growers on, this is the hardest thing to train them on, because they've gone out their whole lives with a wet sprayer and they've soaked the plants down. Training that guy to say, okay, now you need to move at a controlled rate through the greenhouse, doing this, arcing like that on a consistent basis and getting, and trying to be even, that's a hard thing for someone to pick up because it's too close to what they've always done. We're talking about droplets that are smaller than your hair, but typically larger than about 25 to 30 microns. Most of the stuff here falls in the 40 to 50 micron range. That's a droplet that allows me to throw it, aim it, get some distance out of it. It still has some mass so I can get it to move. But at the same time, it's going to fall out. It's not going to float in the air. When we talk about ultra low volume, it's floating for hours. For this, it's minutes. Okay, it's a big enough droplet that you can aim it. But it's still a fine enough droplet that it's got the characteristics of low volume that we want to employ. We're going to use less solution. We're going to get better surface coverage because we've got finer droplets. Okay, this machine here is a 3,000 PSI hydraulic sprayer. That little tank, is designed to treat about an acre. So what we're doing is concentrating the solution more than we would with a regular wet spray. You have to concentrate the chemical a little bit. It looks like a funny crop. It's actually a bunch of basket hangers, so it's not some new white plant that was developed. But again, in the ornamentals industry, we're focusing on tightly spaced plants, very compacted together, a lot of dense foliage a lot of the times. Some of the same things you guys are going to be encountering as you move indoors. You need to maximize that space, so you pack stuff tighter. One thing, you notice the guy's suited well. The Casco helmet is a very nice touch. It's not completely necessary. You do need to have a sealed, anytime you're using droplets that are this small or smaller, you need to have a sealed face mask. You want to be tight, and you need to have the proper cartridges in your respirator. Technique here is something that we addressed after the guy came out. We generally don't like people walking into the spray, but it was a good spray because it showed you how well that small droplet drifted through the canopy and floated all around, because that's what's going to get you good coverage. The more it's swirling, the more fine droplets that are floating around. It almost looks like a fumigation. If you ever see that, you see the stuff floating and drifting through all the nooks and crannies between the plants. That's going to help you get better coverage. Finally, we talk about ultra-low volume. Okay? Ultra-low volume is extremely little amounts of water. We're talking about, less than a couple gallons per acre. Very, very dry application. Okay? You're not getting things wet. You're not even going to see it floating around in the air in most instances. It's not going to be visible on the plants. Sometimes that's actually a good thing. In the ornamentals industry, we're selling plants, which means the foliage has to look nice, the flowers have to look nice. We're not selling a fruit. We don't want to see big droplets and big splatters of pesticide residue all over those leaves. In this instance, the ultra-low volume, or both of the low-volume methods, really don't leave any evidence that you've sprayed them visibly. We're going to be using, again, a reduction in the chemical rates primarily due to the amount of pesticide saved because we're not running it off the plant. We're getting a lot better on-target deposition when we get to finer droplets. When I say that, none of the numbers are inspiring. Basically, if we look at several different studies in the ornamentals industry, the average on-target deposition for hydraulic sprays is 7%. meaning we got 7% of the solution where we wanted it on the leaves. We get up to ultra low volume, it's closer to 30. None of those things are great numbers, but when you consider what we're trying to do, you're gonna have it drifting other places. But you see that ultra low volume gets you actually much better surface coverage and much more efficiency than what you were doing with a wet spray. Typically, as I said, this is going to be used in a walled structure. In this room, we would fill the room, would be our goal. Okay, so there's limitations to this. If I've got plants here that I want to spray and I don't want to spray those, a very common problem in ornamental greenhouses is that you'll have a greenhouse who will have an ornamental plant over here and they'll have an edible plant over there, impatiens and tomatoes in the same greenhouse. Jim Bethke was talking about how many different varieties of plants. We are not monoculture by any sense of the means. Most greenhouses are selling, a lot of them are selling directly to consumers, or they're growing a wide variety to go into the different stores. So you'll have tomatoes over here, and you'll have impatiens over here. Big problem with that is I've only got so many things I can spray on this crop. But over here I got the whitefly that are really making those impatiens look bad. If I'm stuck with what's over here or the least common denominator pesticide, it's not going to be real effective on the impatiens. Something like this allows me to be selective. Something like this allows me to go and spray within 30 feet of the door when I notice I've got a problem that's crept in from the doorway or from a vent that hasn't been properly closed or things like that. So space treatment in this instance, this is going to fill the whole place. Okay? A lot of times that's actually a very beneficial thing. If you've got a monocrop and you've got a pest that has infiltrated that greenhouse, now we can get that whole place either rapidly or fairly efficiently and do a good job. Droplets that are smaller than a quarter of the size of your hair. And what's happening here is these droplets are so small, they're floating around in the air currents in the greenhouse. They're getting up underneath the leaves. One thing that's really, really important with ultra-low volume that's not as important with other methods is what type of airflow do you have in the greenhouse? Do you have a horizontal airflow? That makes a difference to how we would recommend a certain size machine for you. If you've got HAF fans in a greenhouse, we can cover greater distances. One of the things that's really important, you see the little one over there, that's an automatic aerosol generator. That's made to create very small droplets, about 5 microns. So when we looked at that scale, that was where we're creating 19,000 droplets for every droplet the size of your hair. What's happening with that is you have a compressor and it's putting out a slow expulsion of this chemical. But for these things to work, you want some lateral air movement. If we put all that pesticide up into the airspace in the greenhouse and just kind of let it float around a little bit, more of it will settle on the top of the leaves than on the undersides. A lot of our insect pests have found that undersides are a pretty safe place to live, and that's why they all hang out there. So we need to get there as well. Lateral air movement is going to help us do that. When you have a droplet that's basically suspended in the air for 4 to 5 hours, if you're moving air laterally, what ends up happening is a lot of that gets buffeted and blown underneath the plants. It doesn't take a lot of force because this is a very, very small droplet. They will float in there. There's little microcurrents that surround each one of your leaves as air moves through there. And it's that lateral movement that helps deposit typically a 5 to 4 ratio. Basically, 5 particles end up on top and 4 would end up on the bottom. As long as you have good lateral air movement. Depending on your pesticide, that may not be that important. If we've got a good translaminar product, okay, then deposition on the tops of the plant's fine. Literally here we're creating billions and billions of droplets to fill an area. And that's the intent. We've got a couple different methods to do this, just like with the targeted low volume. As I said, we've got the aerosol generators, and then we have these little pulse jet type systems. These are primarily the 2 methods that you're going to use to use for space treatment. There's also aerosol cans that you can buy that have, I'm not even sure if those are labeled. I mean, I think some of those are labeled for the citrus industry, but for indoor greenhouse use. But the whole idea behind those is that you're putting an aerosolized droplet into an area. This is a machine called an autofog, and if you can barely see the spray exiting the nozzle to the left of the machine. What's happening here is this is sitting in a greenhouse. You have air being run to this, which is creating a low pressure area at the tip of the nozzle. Solution is siphoned out of that nozzle, atomized in that airstream, and expelled into the greenhouse. When I talked about particle size range, this is creating a 5 micron droplet, but nothing's bigger than 10 microns. When we get that, these droplets are going to float for a very, very long period of time. You barely notice any haze, and this is after an hour of the machine running. These machines, we make 4 different sizes of these, but the idea here is you have a fan on board when you're going to larger areas, because the fan's going to help you get that lateral air movement that we discussed. That will work up to a certain size, but the machine can do a larger area if you have fans in the greenhouse that are moving the air as well. So depending on how you're setting up your greenhouse, depending how these buildings are arranged, you can cover larger areas if you have good air movement. Less dependent on air movement is going to be the pulse fog. And I must have turned off my volume because this would be loud, although my little speakers wouldn't do a good job of relaying that. But what's happening here is we actually have a small jet engine. This is a pulse jet engine. Gasoline is in the small tank at the back, chemicals in the tank at the front. What you saw the guy doing in that picture was starting the engine by forcing air and gas to mix in a carburetor and blow past a spark plug, which ignites that gasoline mixture. You get that to the right rate of gasoline combustion, you don't need the spark plug anymore. It feeds itself. And then what ends up happening is he's turning a lever right there. That controls the flow of chemical into nozzles up at the front end of the barrel. What ends up happening then is basically that blast of exhaust is giving you propulsion as well as atomization. So as that's expelling, you are throwing the chemical with that size machine, 100, 120 feet. We've got larger machines. We've got smaller machines. But the idea there is that we are atomizing it with that exhaust, and then we are propelling it. It's a little bit different than the automatic versions. The automatic machines use a very, very precise nozzle, a very controlled rate of output. And what ends up happening is you get a very even droplet as a result. The thermofoggers like this, what ends up happening with them is they are very fast. You create that machine right there could treat 50,000 square feet in 30 minutes. The one I've got on the table back there will treat that same area in 15. That machine back there will throw the chemical 200 feet from the machine. So you can treat an area very, very rapidly. The problem is that it's a little more sloppy in the way that it atomizes. It's not shattering the droplets as evenly. As a result, we need to typically use a chemical surfactant, something that's going to reduce the surface tension of the water to help us shatter those droplets more evenly. So we do have to add an additional chemical. Jim Bethke was talking about the use of adjuvants and things like that. Here's a place where that's absolutely necessary with the equipment to do the job. All right, one thing I want to touch on very quickly when we go to the hydraulic sprayers, because you're never going to get away from using hydraulic sprayers. One thing I want you to come away from this talk with is the impression that not one of these tools is a silver bullet. Okay? You need to look at using all of them. Just like tools in a toolbox. Okay, we've got wrenches and hammers. A hammer is meant to pound a nail. A wrench is meant to thread a nut and a bolt together. I can use a wrench to pound a nail. It's not the best way to do it. Okay? That's the same thing with the spray equipment. There's different times where different methods might be better employed. Hydraulic sprays are still going to be a tool of choice. We've got all this fancy ultra-low volume technology, but there's still times when a good hydraulic spray is going to be a better option. When you're getting guns and you're moving indoors, you want to start looking at the flow rates that you are employing. Okay? We don't want 2 gallons a minute. We don't want the high flow, very forceful spray that you're going to use more in a tree application. We want finer droplets. Okay? Anything more than 2 gallons a minute in a greenhouse is going to be too much. I would suggest you get closer to 1 gallon a minute. You want finer sprays. The pressure range. Look at what you're using when you're out there using your hydraulic sprayers. A lot of equipment that you see around the state, has the capacity to do 400 or 500 psi, but people are only using them at 2. In a tree situation, again, that's not as big of a deal. In greenhouse, we can use that atomization to help us get a finer droplet. Okay. Finally, you want to look at the patterns of these guns. All right, what you're used to, a coarse, heavy spray to get you propulsion into a tree canopy, isn't what we want to do indoors. We want to get a finer spray. It might mean you get a little bit less distance out of it. Okay, but generally in a greenhouse, you're going to be packing your plants more densely. You're going to be having less space between them. You're going to need to look at that using the finer droplets to help you get better coverage. We don't want to soak the plants so everything's running off. Look at that width of pattern. We want to get some distance of throw out of this. We want to get it to the plant and not spraying all out sideways. You'll see a wide variety of different guns in the market that will spray at the finest spray pattern. They're going out like this. It's not going to get you any distance. So you want to look at the different types of guns that are out there. Finally, look at the evenness of pattern of these guns. A lot of the different types of pattern adjustments that you'll find on these guns employ methods that off-center, basically that cause the nozzle to be off-center with the shaft on the inside, which is what helps you create that droplet. If they get off-center, typically that's very typical of barrel rotation type guns. Like you've got those brass wash nozzles you use for your house that you bought at the nursery or at a garden center, where you screw the barrel. You get a very fine spray at one point, but if you ever get those and you look at how the pattern actually comes out of that, you get the nozzle out of alignment with the shaft on the inside, and half of that cloud will be a lot wetter and heavier than it will be, than the other side will be. You want to look at different methods of pattern adjustment. Okay? I'm going to quickly skip through the video of the guns because I want to really quickly talk about this before I am dragged off the stage. One thing you're going to hear in a little bit is about the use of neonicotinoids as a drenched product. There's different ways to apply drenches. There's one of the things that may be very effective in a containerized situation if you're using drip irrigation is through drip. But very commonly, this is done as a manual application. In the greenhouse, in the ornamental industry, we have this as a very common application. It's used for fungicides very commonly. It's also used for the same systemic insecticides that you guys are discussing. It's also used for plant growth regulators, where we're actually trying to get a trying to get a physiological response out of the plant. Very common method of doing this is the 1-1000, 2-1000, 1-1000, 2-1000 rate of application. You got an injector or hydraulic sprayer. It's pumping that solution out of a wand of some sort, and you're drenching that into a container. That can be somewhat accurate. You do that all day, I guarantee you your 1-1000, 2-1000 on plant 1 is not the same as it is on plant 10,000. And if you have 3 different people doing that job, they're all not counting exactly the same. It's a very, very laborious method and not always that accurate. Accuracy can be important when we're dealing with some of these chemicals. I haven't seen this in this industry, but in the greenhouse industry, I've actually seen people really concerned about getting the accurate dose, taking a bucket. In a Coke can, they want 12 ounces, so they cut the top off. Depends on where you are in the country. Southeast really likes Coke cans. I've seen other places use Pepsi cans. But they'll cut that off, and that's how they'll go out with a glove, and they'll just dip in and dump it in the plant. Where you want to actually get a very controlled result, you want an exact amount of solution in that container because it's going to affect the growth. Precision is important. One of the things that we developed a number of years ago is a dosing system that kind of combines both of those, accuracy with the ability to just move a wand. The idea here is it's basically an automated system that measures the flow as it goes through. And as we talk about neonicotinoids, one of the real important factors with that is some of those are pretty expensive products. And if you're doing 1/1000, 2/1000, you go 1/1000, 2/1000, you move to the next plant, you didn't count the 3/1000, but that's what hit the floor. So if you're using a neonicotinoid and you're not turning on and off, you're just going from plant to plant, you're wasting 30-some% of that product on the floor. It's a fairly expensive product. I mean, in the greenhouse industry, we found, or in the ornamentals industry, we found a number of growers that have figured out that they are paying for certain equipment with 1 or 2 applications just based on the rate of chemical or the cost of the chemical. So here's a typical ornamental crop that gets this type of treatment, poinsettia. Basically, growers moving through there with a wand, and it's just firing a little dose. So you've got a, let's see. We've got 2 different styles of this machine. One is just a pump and tank that basically just puts the controlled amount out per second. This machine here is actually a separate unit. It's a chest-mounted unit. I've got one in the back that connects up to an injector, connects up to a hydraulic sprayer, and the idea is it's just giving you a dose. They can work on an interval. They can work single shot. But the idea is you get an exact dose in each container. And hopefully, very easy to program. I'm going to skip through that just because it's very simple. If anybody wants to see how they work, I have one in the back. That's going to put me at about 5 minutes that I wanted to really leave for questions. I did want to talk quickly about training. The one thing that I really want to stress on this is as you're moving into the greenhouse industry, okay, this is a different type of application. You want to get the different types of machines out. You want to practice. You want to know how they all work, okay? You want to know how each machine works, what its strengths, what its weaknesses are, because there's going to be times for each type of machine, all right? You want to get out there and try and do different things to get coverage. And really important when you're doing that is you want to make sure that you are gauging your results. As you move into the greenhouse, you want to see if you're actually being effective with these methods. There's different diagnostic tools that you can use to help you with that. Basically, we have ultraviolet dyes. I'm particularly partial to the hydrosensitive paper. Basically, this is, it looks like the yellow sticky card, except when you get this stuff wet, it turns blue. So you get little speckles. This is a great tool to take out into a greenhouse, see if you're actually doing a good job. As you move into a greenhouse, you're going to find constraints as you move around that you didn't have outdoors. You're going to have post lines. You're going to have walls, things that didn't occur before. That's going to change the way you spray. So you want to use these types of tools to make sure that you're actually getting the coverage you're trying to get. Now, these will work down to a certain particle size, and that's why we have the ultraviolet dyes, because you can't do the ultra low volume stuff. It won't really register because the droplets are too small to really register on the paper very well. And also the way the paper works is, or those ultra low volume applications, they typically sit for 4 or 5 hours. Generally, this paper is sensitive enough that if you leave it in a greenhouse for 4 to 5 hours, it's going to be blue, just because of the humidity that's in there. So it'll look like you did a really good job, but it won't be really giving you any good indication. With that, I wanted to make sure that I had any time for some questions.
We got time for a couple of questions, and we need to repeat the question, too.
Yeah.
Questions out there, anyone?
You say about trying different things. How do you get access to different kinds of equipment without purchasing?
Question was whether, how do you get access to different types of equipment? When I say trying different things, what I'm really meaning is trying different things with the existing equipment you have. It's going to be how you target, how you move through the greenhouse, with a regular spray equipment, with something like the ultra low volume stuff. There's not a lot of different technique there. You use it a very specific way. That's more of a targeted low volume or a hydraulic spray type technique.
Question here.
Do you find that are you getting more into, I suppose not, but phytotoxicity with the low volume and high heat in the greenhouses?
It's a very good question. The question was about phytotoxicity when using the low volume methods, especially in a greenhouse. No. In fact, we generally see less phytotoxicity because we don't have the concentration on the leaves that we do. We don't have big concentrations running the edges and stuff. The heat issue is a question that is very important to the way you're going to use any of these methods. Typically, these types of machines, you're going to want to wait until you can close the greenhouse. Okay, which means that's going to be a very specific time of day. You're not going to close the greenhouse at noon because the greenhouse is going to keep heating up. You really need to wait until after the sun has gone down and you're not getting any more solar gain in that greenhouse. You need to be able to close the greenhouse and not ventilate or exhaust the greenhouse for 4 or 5 hours. So a lot of times these application methods, the automatic machines, you set a timer and they turn on by themselves. The thermal foggers, really, that's something where you're going to go in there. It's going to be so fast, but you might be doing it at 8 o'clock at night during certain seasons.
Any other questions? All right. Well, thank you, Kurt, for your presentation. It was very helpful.
Thank you.